What we are going to learn now, guys, how to graph absolute value function. We know that the simplest absolute value function is going to look like this: f of x equal absolute value of x. And we know that the graph of this has to look like a V, where the vertex, at this point here, the most important point, we call it the vertex, is going to be at the origin, 0 and 0. Then it's going to take that shape, which is V. We learned in the class how can we do transformation to a graph, like when we add something to the x or when we multiply the function by something, how all that is going to affect the graph. So we're going to use what we learned in the class to graph something look like this: f of x equals -2 multiplied by absolute value of x minus 1, then we're adding 2. So what we did so far over here, we multiplied this by -2, then we subtracted 1 from the x, and then we're adding 2 to the whole thing. Now this negative here outside, when you multiply by negative number, we know that this is gonna reflect the graph on the x-axis. Like the x-axis is gonna work like a mirror, and then we are gonna reflect it. So this one, when we graph it, is gonna be a V also, but not opening up, it's gonna be open down. But where the vertex is going to be, since we subtracting 1 from the x, that means the graph is gonna move 1 to the right. It's always opposite to this. When this is negative, it moves to the right. If we adding 1, it moves to the left. So this vertex is going to move 1 to the right. Then when we add 2, that's going to be up 2, 1, 2. So that's the new vertex. Instead of being in the origin, it's going to be here. And remember, it's not going to open up, it's going to open down because of this negative. What about this 2? This 2 is going to make the graph stretch vertically, like it's going to be thinner. Now if we want to graph it exactly, we just need to find one more point, because actually we know that since this is the vertex, this is going to be the axis of symmetry. This one here, that's going to be your axis of symmetry. That's going to be your mirror in the middle. So the V is going to be on one side, open down, and then you are going to reflect it on the other side, as we are going to see now. So now I need to find one more point to the right of this vertex. So if this number is 1, let's try to figure out what the value of the function when x is 2. So we are going to plug in 2 in here. So we're going to find f of 2. How we find f of 2? Replace x with 2. So -2, absolute value 2 minus 1. Then we adding 2. 2 minus 1 is 1. Absolute value of 1 is 1. 1 times -2 is -2. Plus this other 2, so the answer is 0. When x is 2, the value of the function is 0. The y is 0. So x is 2, y is 0. So if we plot this point, here is going to be. So now we can draw half of the V. That's the vertex. And we said we are going to flip it, it's going to open down. So it's going to go like this. Now we take this point and we reflect it on the other side. This point is 1 away from that mirror. So the reflection or the image is going to be also 1 away from this. So here we count 1. And that's another point on the graph. And the graph opened down. And this is the vertex. So we draw the other branch of the V. So as you can see, it's flipped because of this negative. Now, you see how wide is this? Now it's not wide anymore because we're multiplying here by number greater than 1. If I multiply by a number between 0 and 1, like half, quarter, what's happened is going to get wider. But when the number is more than 1, it's get thinner. Alright, so that's how we graph it. It's so simple. So now guys, if we have absolute value function, which f of x equal number a absolute value x minus h plus k, then the vertex is the order pair x and y. What this first number here on the order pair is going to be opposite to this. If this is minus 1, then the vertex is going to be positive 1 and 2. So over here is going to be opposite to this, h and k. If there is no number in here, then this h is 0. Like if it's only absolute value of x and there is no other number, then h is 0. If there is no other number outside, then k is 0. So the first thing you do when you want to graph the absolute value function, you decide what the vertex is, you plot the vertex, then you ask yourself, is it going to open up or down? This v is going to open up or down. How you decide that? From whatever that number outside. If that number outside is positive, it's going to open up. If this number is negative, it's going to open down. Then you plot the vertex and you find one more point to the right of this x coordinate of the vertex, and you figure out what is y by substituting. You plot that other point, you draw the axis of symmetry, which is vertical axis going through the vertex. Then you reflect this point on the other side and you draw the other branch and the first branch. Okay, guys? Okay, now we want to learn how to graph a quadratic function. Quadratic function, this is when it has x to the second power. The simplest quadratic function is f of x equal x power 2. So this is the parent function for the quadratic function, the simplest one. Like from this one, we can go to something more complicated, look like this. So what is the parent function for this? 2x minus 2 all squared minus 4, x squared. But we're adding 2 to the x, and then we're multiplying that by 2, and then we're subtracting 4. So this is the parent function of this one. So by doing transformation to the graph of this, we can obtain the other graph. We know that the graph of this is going to look like a parabola, like U letter opening up because there is no negative in here. The vertex of this is going to be 0 and 0. Then it's going to go through 1 and 1 because when x is 1, 1 squared is 1. Then it's going to go through 2 and 4 because when x is 2, 2 squared is 4. And it has to take that curve, which we call it parabola. This is going to be your axis of symmetry. So the other half of the parabola or the other half of the U is going to go on the other side. So we just reflect this on the y-axis. So this point is going to, it's 1 away. So it's going to be 1 away on the other side. This one is 2, 1, 2. It's going to go 1, 2. And the top of negative 2, then we draw the rest of the graph. Now, how can we use this to graph f of x equal to x plus 2 all squared minus 4? Since we're adding 2 inside here, that means that this graph is going to translate horizontally 2 to the left. It's opposite to this. Then it's going to go down 4. So instead of 0 and 0, it's going to go left 2, then down 4. So from 0 and 0, left 2, down 4. So that's going to be your new vertex. Is this function is going to, the graph of this function is going to open up or open down? Since over here it's positive number, it's going to go open down. We are not going to flip it over. So now we need to find 2 more points because this is not straight. I need at least 2 points so I can give it that shape. So what we're going to do, we're going to do like table of values here. We're going to pick 2 values of x to the right of this point, to the right of the x coordinate of the vertex. And then we calculate what the answer is going to be, and we plot these points and we draw the half of the graph, then we flip it over. So if this is x and this is y, we start from x coordinate of the vertex. We are going to go on the x 2 to the left. So that's going to be your vertex, negative 2. And you go down 4. That's your vertex. V. Now we pick 2 points to the right of -2. Even if this is in one of the problem is like a decimal point, we use whole numbers in here. So what to the right of -2? What the first whole number? -1. Then we pick another number, which is going to be 0. Now we plug these two numbers in here and we find the two answers. So if x is -1, what's -1 plus 2? +1. Square the +1. 1 times 1 is 1. Multiplied by 2 is 2. 2 minus 4 is -2. What about when x is 0? 0 plus 2 is 2. Square the 2 is going to be 4. This is 4 times 2, 8. Subtract 4 from 8, you get 4. Now we plot these two other points, -1 and 2. -1, sorry, and -2. -1, and we go down to -2. Remember, this is the vertex, so actually over here that vertical line is going to be your axis of symmetry. So what I'm trying to do now, I'm trying just to graph half of the parabola and then I just reflect it on the other side, as we did before with the absolute value function. So I did plot -1 and -2, now 0 and 4, 0, and you go up 4, 0 on the x, and then you go up 4. Now you plot the other image of this on the other side. This is 1 away from that mirror, so from here you count 1 on the other side. That's another point on the graph. This one is 1, 2 away, so you go from here and you count 1, 2. That's going to be another point. That's going to be on the top of -4. Now we know it's going to open up because this number is positive, so now that's your vertex. That's going to be your lowest points. We call it the minimum point of the minimum point of the graph. Then we try to give it that U shape, or what we call it parabola. All right, guys. So one more time, what we did, we find the vertex first. So if this is your function, what the vertex is going to be? The vertex is going to be vertex equal, order pair, opposite to this. Whatever subtracted or added to the x, we do the opposite. If it's -h, over here is going to be +h. Then the y coordinate is going to be the number outside, so you go up k. This is, we don't change it. If it's positive, it stays positive. If it's negative, it stays negative. But the h is the opposite. If one of these two is missing, then we use 0 for that. So one more time, how we graph it. The first thing, we decide what the vertex is. We do a table of value. Your vertex is going to be the x and the y as the first thing on the table. Then you pick two more x's to the right of this number. You plug them in, you find the answers. You plot the vertex. That's going to be your axis of symmetry. You plot the other 2 points. You draw half of the graph. You flip these 2 points on the other side of the axis of symmetry, and you do the other half of the graph. And you have to give it that nice shape, the parabola. Now guys, you need to try to graph these two problems and bring them to the class.